guys, welcome to this video tutorials. I am Abdul Kadir Lamin, and today we are going to work on another library on parallel programming. So today we are working on openmp programming. First of all, let us define openmp. openmp is just an API for writing multi-threaded application. So it is another library for multiple programming, as we saw recently on openmpi, which was openmpi, which was message passing interface. So now most of the constructive in openmp are compiler directives. We have the syntax to be hash pragma omp constructs. So constructs here stand for what we want the compiler to perform, and in our brackets we will define the clause which will be executed. Now, without further delay, let us start with the simplest program, our hello world program on openmp. Now you will be using C programming language to write the programs. Now we include our openmp library .h, our standard input output as usual, and our lib library lib.h. And as we saw earlier, int main, they are main function, main program. Int argc, argument character. This variable will take all the characters passed in this program. Our character argument vector, which is one dimension vector like a table. So after this we begin the parallel region. It is in this area that we will divide our program into numbers of threads needed. Now we use our directive to our constructive to direct the compiler to divide the programs into parallel number of threads. Now pragma openmp parallel, this is just to begin the parallel region. This number of thread is facultative, but here I have decided to put in place the number of threads needed to perform this our program, and I've decided to use 4 threads. I can use 5, 6, 10 as I like, but for this program let us use 5. Let us save the change. So what will the program perform is just to print hello world and to tell us which thread is sending this message, which thread is performing the computation. Hello world from thread %d, and this function is also a function in the openmp library. It permits us to have the number of thread which is performing the calculation, and normally we end the parallel region here with just these brackets. This is just our hello world program. Move on to the second exercise. We will be looking at the sum of n integers. Now standard input output h library openmp library normally, and here I've decided to define my n to be 5. I'm just summing 5 integers. You can use 10, 1000 as you like. Int main arg sync character constant arg vector. This vector is constant. Now this here function here permits me to have values, the values, correct. Now int tab sum and I. For here we will start our parallel region, pragma openmp parallel. But since I'm using 4 and in the openmpi h library I have the possibility to use a parallel loop. This is known as for openmp parallel 4, and number of threads is 5 since n is defined to 5. Private I. Since we are talking of parallel programming, we know that some programs share memory and others do not share memory. Here we have private I, and our I here is this I 0 to I n. So each loop, each number of iteration will take a value, and this value will be private to the next loop. That is why we are using private here. And at the end we would like to sum all the values in that private, so we are using reduction plus sum by the master thread. So here each thread will show us with value, the summation, but here I'm using 1 1 since I'm having only 5. If I was having maybe 10 or 11 or 15 or even 20, then I could decide to sum 2 2 2 2 before adding at the end. But here it is a small value, so we can just show the uses of private and the use of reduction. At the end we will have our sum, return 0 since we are working with int main, a function. Control save. And lastly, our last exercise will be on matrix multiplication. P thread, standard input output, openmp, and system, the time. We know sometimes when we are using parallel programs it consumes much time, but even though the consumption of this time, it remains the best way of programming, since today we are talking of ships, no more space. So we know that when sharing address, sometimes data conflicts may come across, but since threads communicate data, we have to remedy to this situation. Now there are several methods put in place to remedy to this problem. One of the most used one is synchronization, but we know that synchronization is sometimes expensive in time consumption. Another way could also be change of data access. And in sharing data again, or in performing calculation, the machine may come in situations where use of the CPU may be so critical. So here we use the function of openmp critical. And sometimes we have to use mutual exclusion, so we use atomic function and the loop function, which is our openmp 4 parallel 4. Now we have open set number of threads. This function will permit us to have the value of process running on, and then give the number to the number of threads. Parallel 4 private I, j and k. Since we know in our matrix we have ai, bi and ci, aj, ak are all so on and so forth. So these values will be private. The ai values will be private, but the matrix will be shared for all the loops, between the loops. You have get time of the day, or calculate the time, and print our results. Now I'm working on Ubuntu, so let us execute our program. Okay. Good. We have the list and see. Now let us compile. I can start with our hello world program. So in openmp, to compile the program, we put gcc, or we put the name of the file after compilation, f openmp, and the file, the extension .c. Enter. Smoothly compile. And to run, we put dot slash and the name of the compiled file, hello mp. Enter. Correct. So we defined our threads to 5. Since it is starting from 0, we will have from 0 to 4. Hello world from thread 1, hello world from thread 2, and so on and so forth. We can compile once more and run the program again. You will see the arrangement will change. Now we have 1 0 4 3 2. Firstly we have 1 2 3 4 0. The next program was the sum. This is it. Now let us run. We have sum open mp. Enter an integer. We have 1 2 3 4 5. The sum is 15. Now you can see the sum of the thread 1 is 1, the thread 1 is 2, thread 0 is 1, thread 4 is 5, thread 3 is 4, and thread 2 is 3, but the last sum is 15. Now the last but not the least, our matrix simple. So the compilation is the same for all the programs written in C for openmp. Now they are asking for the number of columns of the first and number of rows and columns. 2 2. Let's say 3 2 1 3. Number of rows, columns, 2 2. Enter the elements. Let's say 2 2 2 2. You have 10 10 8 8. Correct. Back to our program. So it was a short video on openmp. Hope you guys have enjoyed. I would like to invite you to like, share and subscribe. Thank you.